Hey, what up, guys? It is now August 2nd, and I am going to take another crack at Ziglings. I've got a decent amount of stuff I actually do want to show you guys or show people at some point. But I've been doing a lot of work lately, focusing on work, and my other thing is not quite ready to show off. I'm trying to get it to a spot so that I can get a lot of content out of it. So, that means that today we are going back to Ziglings, and I am obviously, it hasn't been too long, right? Let's just see how long it's been since I think which number we're at. We are at it's been 2 months. Okay. Oh well, not a big deal. So let's see if I remember anything. But this is exercise 59 is where we're starting. So let's see. Let's see where we're at. All right, 59, integers. Zig lets you express integer literals in several convenient ways. You wait. Okay. Decimal, hexadecimal, octal, binary, ASCII, or Unicode code points. Okay. You can also place underscores in numbers to aid readability. Okay, makes sense, I guess. I don't like it. I don't. Please fix the message. All right, so let's just run this. What does it say? Run. No step name run. Following command. What? What? Like this all worked last time I was doing it, so if this doesn't work, I'm gonna pause the recording and see where the problem is. There's a play button. Ugh, no step name run. All right, I'll be right back. All right, I have no idea what happened to Sea Lion while I was away. It updated to 2025, and now this build and run command, the command that tries running through here is not the command I want. So I'm gonna do it through the terminal. So looking at here, it wants me. I imagine that I'm supposed to be spelling zig. So if I look at here, this is saying yif. So we need to add one here. So this is octal. I don't know, I imagine that I can just add a 2 here. Again, what did I do? 133, 134. I don't know. So the original is 131. So we're going to 132. Here we're going to add 1 and FG. So it looks like we're just adding 1 to everything. Now if we run that, Zig is cool. Cool. All right, that's it. 60. Zig has support for floating points in F80. Nutty. Many different ways. Well, scientific notation, underscores in the middle. Yeah. Okay. Hex floats can't use the letter E because that's a hex digit, so we use P instead. Okay. Nutty. Be sure to use a float type that's large enough to store your value. Rounding may or may not be okay, but numbers which are too large or too small become int for minus int. Rounds to, what's it? Avogadro's infinity. I don't know what that is, but who cares? Performing math operating with numerator, ensure the type match. Zig does not perform unsafe type coercions behind your back. Float 16.5. Literal of a different type. Equal foo. Okay. All right. So let's do 60. Let's see what happens. This is telling me shuttle liftoff in metric tons. Okay. 2 float problem with the program. The approximate weight of the space shuttle upon liftoff, including boosters, is this. I mean, I'm just going to guess that this is probably supposed to be a 32. What does that change? Okay. Further, I don't know. It says 2 floating. There's supposed to be 2 problems. Tell me what the expected solution is. That's what the only problem is. I don't know what the expected solution is here. And frankly, I don't really care about this crap. So, but let's look. Space shuttle upon liftoff is 4,480,000 pounds. Okay. We'll convert this weight from pounds to metric units at a conversion. Okay, so let's, is there a weight converter here? Converter, currency, volume, length, weight, mass. So what is this? 4,480,000. 2 million. So 2032,092. E3, it means that this changes. I'm missing a 0. 1, 2, 3. 2, 3. That's correct. I think. Two zero three two 092. Maybe that's correct. I mean, it's close. 2032,092. About equal. I mean, can I say close enough? I don't know what the other problem was. What if I do 64? I'll just change it to 64. What happens? Well, I get the... Oh, it's the same thing. So one of the problems was that it wasn't big enough. Format in scientific notation. Try experimenting with D and to C. Oh. Okay. What if I just do D? Okay. Hex floats. I mean, okay, I'm just gonna say call this done. It's close enough, right? I mean, it's close enough. I don't care. If it becomes a problem, I can. 6 is half precision binary floating point binary state, which is stored in memory, blah, 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 blah. This example is a decimal number 3.140625, which happens to be the close representative pi we can make with a 60-digit time bit, blah, blah, blah. Save space by modifying these values. The value was always subtracted from the exponent bits, and blah, blah. I don't care about this. Feel free to forget the implementation details immediately. Done. Coercions. It only takes us a moment to learn Zig type coercion rules because they're quite logical. Types can always be made more restrictive. 8, pointer to 8. And then mutable to immutable. Okay. Right? And of course, the larger types, yeah, that makes sense. Because you can put a 5 into something like, you can put an 8 into a 16, but you can't really put a 16 into an 8. Single item pointers to arrays correspond to slices and many item pointers. So here, pointer to this becomes a slice to a many item pointer. Sure, I don't know. What are you even getting at here? Single item mutable pointer that can coerce a single item pointers point to an array length 1. I forgot all the syntax. I don't like this syntax at all. Single item mutable pointers can coerce to single item pointers pointing to an array of length 1. Single item mutable pointers. So here, can coerce to single item pointers pointing to an array length of 1. Okay. So you can coerce this into being an array. A pointer to an array. Payload types and null coerce to optionals. Pointer type, payload types. Okay. Yeah, so you can turn it into an optional. Payload types and errors coerce to error unions. Error, character or die, my error equal character, and then we can tell it it's an error. Okay. Undefined courses to any type. Sure. Compile time numbers course to compatible types. Just about every single exercise program has had an example of this, but a full and proper explanation is coming your way soon in the third eye-opening subject of comp time. Tagged unions course to current tagged enum. Enum's course to a tagged union when that tagged field is a zero-length type that has only one value, like 0-bit types like void can be coerced into single item pointers. But you're more than welcome. All right. Okay. What your type here must coerce letter from and letter, which is a U int. Rules 4 and 5. This is what I was thinking of. I'm like, this is do. So I can like take this and like shove it in here. Zig run 061. But it needs to be an optional. So I do that. Is that what I'm doing? I don't know if I like that. It's taking a while. Yeah, it worked. Yeah, okay. That's so gross. It's so gross. But it worked. Okay. 62 loops. Remember using if-else statements as expressions like this? Sure. Zig also lets you use for and while loops as expression. So like the Python does it, right? They're called something. I don't remember what they're called in Python. Like return for functions, you can return a value from a loop block with a break. Break true. Well, what value is returned from a loop if a break statement is never reached? We need a default expression. Thankfully, Zig loops also have an else clauses. As you might have guessed, the else clause is evaluated when 1. A while condition becomes false, or 2. A for loop runs out of items. While true, break 2. Okay, so the default for this, break else 0. Okay. If you do not provide an else clause, an empty one will be provided for you, which will evaluate to the void type, which is probably not what you want. So consider the else clause essential when using loops as expressions. With that in mind, see if you can fix a problem in this program. Things, languages. Let's find the first language with a 3 letter. There is no else. With a 3-letter name and return it from the loop. Okay. And this is an optional, so it can return what else under else null. Is that what I want? I'm gonna turn off Copilot. I thought of that one before Copilot gave it to me, but yeah. So let's see, Zig 062. Not zip yet, jerk. Zig run. Yeah, sure. Stupid sea lion not doing this properly. Current language Zig. Yes. Now if I get rid of this, oh, can I do this? Can I just do it like that? Just say, hey, it'll be, do not separate the syntax Erlang. Okay. What if I do this? Does this work? Underscore. There we go. I don't know why you would. Unable to infer array size. Why aren't you unable to infer array size? Fine. I hate it. Just saying. Okay, so that worked. All right, 63 labels. Wait, was there anything else in here? No. Labels. Loop bodies are blocks, which are also expressions. We've seen how they can be used to evaluate and return values. To further expand this concept, it turns out we can also give names to blocks by applying a label. Once you give a block a label, you can use break to exit from that block. Break outer block. Oh. It's kind of like inverse go-tos or some shit. As we've learned, you can return a value for using a break statement. Does that mean you can return a value from any label block? Yes, it does. Labels can also be used with loops. Being able to break out of nested loops at a specific level is one of those things that you won't use every day, but when the time comes, it's incredibly convenient. That is true, that it does happen sometimes where you need to break multiple times. Being able to return value from an inner loop is sometimes so handy it almost feels like cheating. Yeah, temporary variables, blah, blah, blah. Yeah. In the above example, the break exits from the outer loop, labeled to loop, and returns a value 2. The else clause is attached to the outer to loop and would be evaluated if the loop somehow ended without the break having been called. Finally, you can also use block labels with a continue statement. Continue my while. So that just says, oh, to do the continue on the outer loop. Okay. I think that's what that means. Continue on the outer loop. As mentioned before, we'll soon understand why these two numbers don't need explicit types. Hang in there. It's because it's comp time int. See? It says comp time int. Food type. Cool. Sure. This is ingredients. Sure. False, true, false, true. True, true, false, false. False, true, true, false. True, false, false, true. Okay, so these are correct. Welcome to the Cafeteria USA. Choose your favorite ingredients and we'll produce a delicious meal. Cafeteria customer note, all ingredient combinations make a meal. The default meal is macaroni and cheese. Software developer note, hard coding the ingredient numbers based on array will be fine for our tiny example, but it would be downright criminal in a real application. Chili and cheese. Look at each food in the menu. Okay. Now look at each required ingredient for the food. Food requires... I guess this is just... What's the syntax do? I don't know. I'm sure we looked it up. We knew about it at some point. It's some sort of range, I'm sure. Required ingredient. This ingredient isn't required, so skip it. For each food in the menu. Okay. The food requires required ingredient. See if the customer wanted this ingredient. Remember that wanted will be the index number of the ingredient. Wanted will be the index number of the ingredient based on its position in the required ingredient list for each food. Const found bool. For wanted ingredients, wanted is captured. Is that the capture? No, this is for each wanted ingredient. It's going to be wanted. If the required ingredient is equal to wanted, then we break true, which returns true. Forgot to return mac and cheese. Else returned mac and cheese. What is it? Zero? Else zero? Is that it? Run 063. compatible type void and comp type. This one? No. The required thing we're all wanted for this food. Please return this food. What's the food? Food. Return. Else. What is it? Foods. Menu 0? Is that it? Menu 0? Is that it? Hey, it worked. Alright, so that worked out. I'm not sure I fully get the syntax here. Where? Because this is breaking. This is breaking here-ish. Should be breaking this. Break true. If we get this far, the required ingredients were all found. So like why? Continue. So like I just don't understand where this break true is going. Found, break true. Okay, it's going to false. Found. Okay, I'm dumb. I'm a dum-dum. All right. It's going into this found loop. If it didn't find it, then it continues. We did not find this requirement, so we can't make this food. Continue the outer loop. Continue the food loop. Oh yeah, so try the next menu item. Okay. Okay, I get it. I get it. I get it. All right. Built-ins. Where are we going to go? Oof, I don't know if we're going to go that far today, because we're already 22 minutes into this video. We might get a couple built-ins, and then maybe we do comp time in the next ones. That's a lot of these, huh? All right, built-ins. The Zig compiler provides built-in functions. You've already gotten used to seeing an import statement at the top of every Zigling. Also seen int cast, int from enum. Built-ins are special because they're intrinsic to the Zig language itself, as opposed to being provided in the standard library. They are also special because they can provide functionality that is only possible with the help from the compiler, such as type introspection, the ability to examine type properties from within a program. Zig contains over 100 built-in functions. We're certainly not going to cover them all, but we can look at some. Before we begin, know that many built-in functions have parameters marked as comp time. Probably fairly clear what we mean when we say that these parameters need to be known at compile time. The rest assured we'll be doing the comp time subject real just as soon. I'm actually kind of excited for comp time. I've been looking at templating in C++, and that's kind of a pain in the ass, and maybe doing some Zig comp time stuff will help me with the C++ stuff. The second built-in alphabetically is add with overflow and BR numbers of any type. The return value is a tuple with the result and a possible overflow bit. Let's try it with a tiny 4-bit integer size to make it clear. This, add with overflow. Check out our fancy formatting. B bigger, greater than 4 means print as a binary number. 0 pad right aligned 4 digits. I see. The print below will produce 11010101 equal 0010. True. Because then there's an overflow bit. Let's make sense of this answer. The value of B is in decimal is 5. Let's add 5 to A, but go one by one to see where it overflows. Let's add 5 to A. Okay. So 101 plus 1 here. 1001111 false. 111 plus 0001 True. 0, 0, 0, 0, 1. False. In the last two lines, the value of A is corrupted because there was an overflow in line 3, but the operations in line 4 and 5 themselves do not overflow. There is a difference between a value that overflowed at some point and is now corrupted, a single operation that overflows and maybe causes subsequent errors. In practice, we usually notice the overflowed value first and have to work our way backwards to the operation that caused the overflow. If there was no overflow at all while adding 5 to A, what value would my result hold? Write the answer into expected result. Into U8. So it would be here, let me look at this. So this would be 1 like this, and then it would be 1 0 0 0 1 1 0 0 0 0 like this, right? So it'd be what? 0 B B 1 0 0 1 0, right? How you do decimals? Yeah. Here's the fun one. Bit reverse. Integer is the value to reverse. The return value will be the same type with the value bits reverts. Now it's your turn. See if you can fix this attempt to use the built-in reverse to reverse the bits of a U8 integer. Tupni bit reverse. 8-bit. That's the right count. Bit reverse. What's this say? Expected 1. Oh. What's that? All right. Zig run with 64. Let's see what this says. Without overflow 10010. I think that's correct. Let's do. Is there a binary? Is there a binary in here? Standard programmer. Ooh, binary. So let's see. We would do 1101 plus 0101 0101 equal 10010 10010. Yay! And that worked out. Sweet. And built-ins, and this will be our last one for today, and we'll look into comp time next time. Or maybe we might do the first comp time. Let's see. Depends how long. Zig has built-in functions for mathematical operations such as square root, sine, cosine, exponent, log, and floor. Lots of typecasting operations such as, error from int, float from int, pointer from int from pointer, int from enum. Spending part of a rainy day skimming through the complete list of built-ins in the official Zig documentation, there's some seriously cool features in there such as call, compile log, emd file, and source. For now, we're going to complete our examination built-ins by exploring just 3 of Zig's many introspection abilities. The this type returns the innermost struct, enum, or union that a function calls inside. Type info, comp time d type, import standard built-in type, returns information about any type in a data structure which will contain different information depending on which type you're examining. And type of type returns a type common to all input parameters, each of which may be in any expression. The type is resolved using the same pure type resolution process the compiler itself uses when inferring types. Notice how the 2 functions which return types start with uppercase letters. This is a standard naming practice in Zig. Okay. Narcissus, echo void. Return this. Fetch the most beautiful type. Oops, we cannot leave the me and myself fields undefined. So, myself is equal to, I guess it's the same thing, right? This determines a pure type from 3 separate references. They just happen to all be the same object. Okay. What's a pure type? Oh dear, we seem to have done something wrong when calling this function. We called it as a method, which would work if it had a self parameter, but it doesn't, see above. The fix for this is very subtle, but it makes a big difference. Const type 2 is equal Narcissus fetch the most beautiful type. Now we print a pithy statement about Narcissus. Narcissus loves all Narcissuses. His final words, as he was looking in the waters, as he habitually watched, were, "Lost my beloved boy in vain." The place gave every word back in reply. He cried, "Farewell." An echo crawled, "Farewell." He has room in his heart for... Am I supposed to give it is this... am I supposed to put something in here? A struct fields array, type info, struct fields. Fields is a slice of struct fields. Okay. Name. Please note, please complete these if statements so that the field name will not be printed if the field is of type void. If field type yuck, look at all that repeated code above. I don't know about you, but it makes me itchy. Alas, we can't use a regular for loop here because fields can only be evaluated at comp time. Seems like we're overdue to learn about comp time stuff, doesn't it? Don't worry, we'll get there. No, this exercise did not originally include the function below, but a change after Zig added the source file name to the type Narcissus became built-ins to Narcissus. To fix this, we've added this function to strip the file name from the front of the type name. It returns a slice of the type name starting at the index 1 of the character this. We'll be seeing type name again in exercise 70. For now, you can see that it takes a type and returns a U8 string. Okay, let's see what this does. Zig run 065. Is not a member function. Let's see. What's going on here? Zig struct Narcissus. Fetch the most beautiful type is not a member function. Of what? Const type 2. The fix for this is very subtle. No field or member function named. Oh dear, we seem to have something wrong when calling this function. We called it as a method, which would work if it had a self parameter, but it doesn't. See above. Shit, what is this problem? Very subtle, but it makes a big difference. I'm going to ask Copilot because I don't know. I actually have no idea. Copilot, give me the answer. Calling it, but it isn't. It's not. It's a plain function. It said you likely need to call it. Oh, like this. A narcissist loves all narcissuses. He has room in his heart for me, myself. Okay, that worked. Okay, so maximum narcissism. That's funny. Type name. Yeah, and it just so this added the source file name to the type. I see. So it just removes this. Okay, and it just removes the period. Everything before the period. Okay, this makes sense because it's not this. So this is like if it was in C++, I guess this would be like, where is it? This would be like Narcissus, and it would be like this, right? C++. That makes sense. I forgot about the whole, this would have to have like a, if I do that, oops, if I do this, what am I typing? If I do that, Missing parameter type. Oh, can I do this? How does that work? I don't care. Let's see if we can figure it out. Structs. Methods. Self. That's what it was. Pub function. Okay. To be fair, I did remember that, but why didn't it work? Like what? Oh, like if I go like self, and then yeah, colon Narcissus. No, do I need to do pub? Why isn't that working? Oh, it's because it's not being used. Can I do this? And then like this. Call the function with the comp time only return type is evaluated at comp time. Yeah, okay, so that's why. Because it's a comp time thing. It can't be. All right. Makes sense. Okay, well that's it. That's my Ziglings adventure for today. We didn't get that much done, did we? What did we do? We started at integers. We only got 7 done in 40 minutes. So hopefully that was not too boring to listen to, or maybe it was and you were looking for something to fall asleep. I don't know. Anyways, next time we'll do comp time. I don't want to wait as long, but to do the next one, but yeah, it is what it is. See ya.